I wish to give a full course in quantum mechanics. This lecture deals with origin to quantum physics, particularly about the wave packet. Kindly subscribe my channel youtube.com/ at Vasuvphysics. Now we will spend 2 or 3 minutes to find the origin of quantum mechanics. First origin for quantum mechanics is the dual character of the electromagnetic radiation. Say, for example, Davis and Zermer and Thomson during 1927 and 28, they found wave nature of electron. Of course, electron is a particle; it behaves like waves. So they found the electron. They have done the experiment and they found the electron type fraction. And in 1924 itself, D. Broglie gave a hypothesis that the dual nature of the particle, that is, particle will behave like particle as well as waves. And also another reason for the existence of quantum mechanics is the existence of discrete value for physical quantity. So before 19th century, uh, we found that all the physical quantities are continuous one. During 1900, uh, it is found that the physical quantities are quantized. That is, a best example is Planck body radiation. That is Planck. He introduced a constant H. So the energy is quantized, and next one is Einstein photoelectric effect. In 1904, he explained about the quantization of energy and as well as Compton effect. So, because of the dual nature, gives the birth of quantum mechanics. Another important concept in quantum mechanics is Heisenberg uncertainty principle. There is no classical analog to this principle. Uh, that is, it says you cannot measure accurately simultaneously the two canonically conjugated parameter. Say, for example, position and momentum. You cannot measure position and momentum accurately simultaneously. That is more important. There is a minimum uncertainty of h cross pi 2. So delta x into delta px is equal to or greater than h cross pi 2. I can explain this with a simple example. Let us say you have one particle, the electron. Though electron is a particle, according to de Broglie hypothesis, it will act as a wave also, dual nature. So you can associate wavelength to this electron. So in order to measure the position accurately, you have to illuminate with light. That is, you have to use electron microscope. So you have to illuminate the light of wavelength which is lower than this particle. That is, low wavelength means high energy. So you can measure the position accurately, but what will happen to the momentum? Because due to the high energy radiation, this momentum will get changed. It will move away due to some extra energy. Then, if you want to measure the momentum when uh, when it moves from here to here, you can measure the maybe here to somewhere else. If there is any displacement, using time, you can measure the velocity. So mass into velocity gives you the momentum. However, in that case, you cannot measure the position accurately. So that is the meaning of this. So delta x into delta px is greater than or equal to h cross pi 2. I have already explained h cross itself is a small number. Then why we have to divide it by 2. That also That is because um, the angular frequency 2 pi mu and wave vector 2 pi by lambda, everywhere that you will get that 2. Everywhere 2 will come. So for mathematical simplicity, we are having 2. H cross over 2. Not only that, if you multiply this both side by omega, you will get H cross omega by 2, half H cross omega. That is that minimum energy, ground state energy. So if you multiply both side omega, you will get this is half H cross omega. That will be the minimum energy, ground state energy of the particle. Similarly, you cannot measure the energy and time accurately simultaneously. There is a inaccuracy in it. Uh, Same thing is for the angular displacement. Angular displacement, we will see that that is along z direction, and angular momentum along z direction. Here, here you can notice that uh, that is linear momentum along x direction will not um, linear momentum along x direction and x displacement along x direction you cannot measure simultaneously. However, you can measure the displacement in y direction and momentum in x direction, similarly in z direction. Only you cannot measure the momentum in x direction and position in x direction. So it can be generalized that delta A into delta P, A and P are the operator, which is greater than or equal to half modulus of the expectation value of commutation of A with P. This commutation and the expectation value we will see in detail in the next class. The dual nature of the quantum particle, how to measure it, describes the material particle by a wave function. We can use the wave function concept. It's a function which describes both the particle as well as wave nature of the quantum matter by wave function corresponding to the matter wave associated with the particle by from the Broglie hypothesis. According to Broglie hypothesis, wavelength associated with matter is equal to h by p, where p is the momentum. The wave function, however, depends on whole space, hence they cannot be localized. Say this particle is moving like this sinusoidal at a fixed momentum. That means fixed energy means fixed frequency. That is the energy is equal to p squared over 2m. So you can here with this single sine wave you can easily define the momentum or energy which is equal to Hz cross omega, same frequency means. But however, what about the position of the particle? The particle may be anywhere between minus infinite to plus infinite. So you cannot measure the position accurately. However, you can measure the momentum accurately. A particle which is localized within a certain region of space can be described by a matter wave whose amplitude is large in that region and zero outside it. Which we are going to see the pictorial representation of the same in my next slide. A localized wave function is called wave packet. A wave packet therefore consists of a group of waves of slightly different wavelengths with phase and amplitude. So chosen that they interfere constructively over a small region of space and destructively elsewhere, which we are going to see now. Now we will see about the phase velocity. Before finding the phase velocity, now we will see how the wave packet is constructed. The wave packet is constructed by superposing the so many sine wave of different frequency, different amplitude, different phase. So, this we have seen in detail in my lecture Fourier synthesis and analysis. By adding sinusoidal wave, you can construct a square wave, rectangular wave, or sawtooth wave, triangular wave, even some random function like this. You can construct using sine wave of different frequency and different amplitude, different phase. Because of that, you got this wave packet. Here one packet, here one packet. Here you can find the particle within this range. That is in the red color region. Your particle is now within this range. That is, you have narrowed down the particle. Unlike a single sine wave, you cannot where in which you cannot find the particle position, maybe from minus infinite to plus infinite. Here you can find the particle position. You can still narrow down. You can bring this close to zero by adding so many sine wave. Now your position is more or less fixed. Position, you can measure the position accurately, but what about the momentum? Because it contains so many sine wave of a different energy, that means a different momentum. So now you cannot measure the momentum accurately. Previous case, as for a single sine wave, you can find the momentum p squared over 2m. Energy is constant, so momentum also constant. You can measure the momentum accurately, but not the position. But that is the important of Heisenberg conservative principle. You cannot measure position and momentum accurately simultaneously. That is more important. Now we will find the phase velocity. Phase velocity is equal to nu multiplied with lambda. Nu can be written as divided by h. That is E is h nu. So this will become cancelled. It is nu. Similarly, using de Broglie hypothesis, you can write lambda is equal to h by p. Now this h will get cancelled. So you will get E by p. Uh, so Vp is equal to E, you know, is half mv squared, and P is equal to mass into velocity. Here mm will get cancelled, and this V will get cancelled with this V squared. So V squared will become V. So you will get half V. That is, the base velocity of matter field is one of the particle velocity. It is half of the particle velocity. Uh, that is, this has no experimental consequence. That means you cannot measure the base velocity of pure harmonic wave directly. So, however, you can measure the group velocity, which we are going to see now. So we got the wave packet like this. This process is called localization or localized wave function. The uh, velocity in which individual waves travel is phase velocity. Just now we have seen the group velocity. See, if you join all the envelope, you can see this green color envelope. So that is another sinusoidal wave. It has a frequency which is average of this group. That is the velocity in which the all the particle travels. That is group velocity. This is group velocity. Group velocity is equal to t omega over tk. That is, this is a dispersion relation. This group velocity peaked around k naught. That I will come to it later. So we know H cross omega, that is energy. Energy is equal to P squared over 2m. You know, P squared is equal to H cross squared K squared over 2m. Here, you can cancel this H cross with this H cross square. So here this will become simply H cross. So omega is equal to H cross K squared over 2m. Now, what is the group velocity, which is equal to T omega over Tk? Now, you differentiate this. Omega is equal to H cross K squared over 2m. So, if you differentiate with respect to K, you will get 2 H cross K. Here, 2 will get cancelled. 2 will get cancelled. So you will get H cross K, which is equal to momentum, mass into velocity. So here one mass will get cancelled. So H cross K over M, P by M is equal to velocity. This is the velocity of the particle. So the group velocity is equal to the velocity of the particle. So you can measure experimentally. This is the simplest and most used wave packet is Gaussian wave packet. It is not necessarily you can generate Gaussian wave packet. The one of the major advantage of Gaussian wave packet is it may be constructed most easily in reciprocal phase. So that is, if you take a Fourier transform of Gaussian wave, you will get same Gaussian wave. That is the facility of this Gaussian wave packet. Now we have seen how we have constructed the localized wave packet. Localized wave packet we have constructed by adding so many sine waves. That is summation. If it is discrete, it will become a summation. But we are going to see it for a continuous change in the momentum. So summation will become integral. Like unlike Fourier, the Fourier series is summation. Here it is integration. So the localized wave function is defined as psi, which is a function of x and t is defined as 1 over square root of 2 pi. This is the normalization constant. A integral over minus infinite to plus infinite uh, pi of k e power I kx minus omega t into tk. Here, the pi of k is the amplitude of the frequency, and this kx omega is the phase. Kx minus omega t is the phase. So, uh, now, if you take time as 0, this omega t will go away because t is 0. So, psi x of t is equal to psi naught x, which is a function of x, is equal to 1 over square root of 2 pi integral minus infinite to plus infinite pi of k e power I kx. You know very well into tk, of course. This is the plane wave wave function, plane wave equation for the plane wave e power I kx. Uh, s- so how to now the task is how to find pi of k. Pi of k, just you take the inverse of it. Pi of k is equal to 1 over square root of 2 pi integral minus infinite to plus infinite. This psi naught x e power minus ikx dx. This is called Fourier transformation. As I said, for Gaussian wave, Fourier transformation is this. You will get same Fourier transform it, you will get again the Gaussian wave. This is the Fourier transform. Here you can find the amplitude of the particular wave. So you can substitute it here and you can find out the wave function. So this is the important point here. In summary, The particle is represented not by a single T Broglie wave of well-defined frequency and wavelength. Just now we have seen it, but by a wave packet that is obtained by adding many waves of different frequency. That is from the wave function we can find out the probability. That is uh, this wave function is nothing but probability amplitude. If you take modulus square of it and integrate it, you will get probability. You will get a probability. So integral over minus infinite to plus infinite, modulus of phi naught x squared is tx is equal to integral over minus infinite to plus infinite modulus pi of k squared is tk, both are same. Whether it is in position representation or the k representation, so it will probability will not change. We have seen phi, which is a function of x and t, is equal to 1 over square root of 2 pi integral minus infinite to plus infinite pi of k e power I kx minus omega t into tk. Here, I like to highlight one important point, that we can extract the information about the particle's motion by simply expressing it corresponding matter wave in terms of particles energy E and momentum P, using the fact that K is equal to uh, P over H cross from T Broglie hypothesis. So Tk is equal to Tp over H cross. E is equal to H cross omega. And redefining the pi amplitude as pi tilde p. This tilde represents the Fourier transformation, which is equal to pi, which is a function of k over h cross. We are redefining it. So you substitute all this here in this equation. One H cross, we are see, we replace tk, this tk pi tp pi H cross. So H cross comes here 1 over square root of 2 pi H cross. That H cross comes because we are replacing tk pi tp pi H cross. And pi of k pi pi tilde p and e power minus I kx. This kx we are replacing by p by h cross, and this h cross omega we are replacing e by h cross. So this psi x x and t is equal to 1 over square root of 2 pi h cross integral minus infinite to plus infinite pi tilde p e power I px minus et over h cross dp. Then if t equal to 0, then psi naught t will become 1 over 2 pi h cross integral minus infinite to plus infinite phi tilde p e power ipx over h cross into dp. So this is the Fourier transformation. Now we have seen psi naught x is equal to 1 over square root of 2 pi h cross integral minus infinite to plus infinite tilde pi, which is a function of p e power I px over h cross dp. So this way you can find out the wave function when time t equal to 0. Here, this expansion coefficient or probability amplitude is tilde tilde pi p. Normally, we will use the symbol tilde pi for Fourier transformation. And tilde pi p is equal to 1 over the square root of 2 pi h cross into integral minus infinite to plus infinite psi naught x e power minus ip x over h cross dx. This is called Fourier transformation. That is, you are changing the position basis to momentum basis. This is called the inverse Fourier transformation. Transformation. You are changing the momentum basis to position basis. Here, first case you take the wave function is position basis. If you take modulus square of it, you will get probability. Y-axis is probability, and the x-axis, this is the x-axis is the position. So you will get a wave pattern like this. You will get maximum at the maximum probability at x equal to 0. Then it will keep on decreasing and it will become 0 when x is a larger value. Same is the case with momentum. That is k. Uh, Psi of k, which is inverse of this. Psi of pi of k squared modulus pi of k squared versus k. This is the probability. You will get maximum probability at k naught. When you are moving far away from k naught, you will get the probability become 0. These two are not independent. You remember that. You have to keep that in your mind that it is not independent because of simple reason that we have to apply uncertainty principle. If you are able to measure the position accurately, you cannot measure the momentum and vice versa. So these two are not independent. These two are related one. Thank you very much for watching my videos and supporting me continuously. If you have any question or comments, kindly send it to me through email ID vasumku at gmail.com. My YouTube channel ID is youtube.com/at vasuvp6. Thank you very much for watching my video.